Start, sir.
Okay, sir. Thank you. Welcome to this session. Today's session, I am explaining about the oxygen family, and also this group also called as 16th group or 60th group elements. From this chapter, you have to get the 4 marks or 8 marks. Okay. So let's I am enter into our chapter, that is oxygen family. Okay. Here in oxygen family, we have to read about the following elements, like oxygen, sulfur, selenium, and tellurium. Last one, that is polonium. Okay, the oxygen family is containing these following elements. Number one, oxygen, sulfur, selenium, tellurium. Last one, that is polonium. Okay, so here the electronic configurations of oxygen, sulfur, these all elements, right? Okay, here the atomic number of oxygen is 8. The electronic configuration is 2s2 2p4. Similarly, the sulfur atomic number of sulfur is 16. The electronic configuration is 3s2 3p4. Similarly, selenium atomic number is 34. Electronic configuration is 3d10 4s2 4p4. Tellurium, the atomic number is 52. The electronic configuration is 4d10. Okay, 4d10 here, 4d10 5s2 5p4. Similarly, the last one, that is polonium. Okay, the symbol is PO. The atomic number is 84. The electronic configuration is, that is xenon 4f14 5d10 6s2 6p4. Here, by using this all outermost electronic configuration, we have to conclude that always here S2p4, 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 like this S2p4. What you understood during this one? Just we have to simplify this one. Only always the electronic configuration of oxygen group is NS2NP4. We have to represent as the NS2NP4. N means what? Any number like 2, 3, 4, whatever may be. That's why the common outermost electronic configuration of oxygen family is NS2NP4. Okay, here how many electrons are there in NS2NP4? That means what? Here s orbital is containing 2 electrons, p orbital is containing 4 electrons. That means what? The 2 plus 4 total 6 electrons. Okay, that's why this is also called as 60A group elements. 60A group elements. Always the valency electrons are equal to their group number. It is a tip to remember a long time. Always valency electrons are is equal to their group number. That's why it is also called as 60A group elements. And also the oxygen family also called as chalcogen family. Chalcogen family. What is the reason why this group is called as chalcogen? Because of these all elements like oxygen, sulfur, these all elements are extracted from ores. Okay, therefore this group is called as chalcogen family. Okay, so this is about the elements, their atomic number and their electronic configuration of oxygen family. Okay, then here occurrence of oxygen family. Here oxygen is most abundant of all the elements on the earth. Oxygen forms about 47% by mass of earth crust. That means what? Here oxygen is a second most abundant in the nature. Oxygen is a second most abundant in the nature. As well as here the abundance of sulfur in the earth crust only 0.03 to 0.1%. Always the sulfur is it is combined as a sulfate such as a gypsum. That means what? The sulfur is very less abundant in the earth crust. It is also found as the combines with the sulfate, the such as gypsum. That means what? The gypsum is containing sulfur. Okay, so then similarly here selenium and tellurium are also found as metal ores. Okay, selenium as well as tellurium both are found as the metal ores. Okay, so this is about the occurrence of the oxygen family. Then oxygen family. Here, this is also called, just I told you, 16 group elements. The group number is 6. The number of valence electrons are, just I told you, 6. Okay. Why? Because 6, it is called as NS2. The outermost electronic configuration is NS2, NP4. 2 plus 4, 6. Like that. Okay. Here, physical properties. There is available 3 non-metals, 2 metalloids, and then 1 metal. Okay. Then chemical properties. It is shares the electrons with non-metals and gains from metals. This is about the some chemical properties. Then reactivity. It will show the more reactive. That's why high. It is show the high reactive, but not as high as the halogen. Okay. Then states of matter. States of matter. That means what? These all elements are exhibit the solids and gaseous states. Okay. Then bonds well with others. That means what? Other non-metals in groups. Okay. Then elemental state. I mean, elementary family is here. Elemental family is oxygen, sulfur, selenium, polonium, polonium. Okay. How to leave this one LV. Okay. Then uses or are found in. Always the oxygen is present in the air or water. Then sulfur is present in eggs. Then selenium, it is present in copies. Then telonium, it is present in thermoelectric coolers. Then polonium, anti-static brushes. Okay. LV, how to leave it? Why? Because it is present still now, it is in research purpose. Okay. So then here, atomic and ionic radii. So here we discussed in P block 15 group elements. What is the meaning of atomic radius? The distance in between nucleus and valence electrons. The distance is called atomic radius. Okay. Here, covalent and ionic radii increases in size down the groups. That means what? Always covalent radii as well as ionic radii is increases in the groups. That means what? Why? Because ionic radii and also covalent radii increases. Only reason is in groups always atomic size is increases down the groups. That means what? By increasing atomic number, increases the atomic size and also increases the ionic or covalent radii in the down the groups. Okay. So here one note is there, atomic radii and ionic radii is increases down the groups because of increasing atomic size. Okay. So this is about the atomic and ionic radii. Radii nothing but it is a plural word of the atomic radius. Then ionization enthalpy, which is represented by IE symbol. What is the meaning of ionization enthalpy? That means what? Simply how to explain by using definition. What is that definition means? The amount of energy is required to eliminate the one electron from their isolated gaseous system is called ionization enthalpy. Ionization enthalpy also called as ionization energy. Okay, my dear students. Okay. Then here, for example, here ionization enthalpy values are decreases down the groups because of increasing atomic size down the group. That means what? Here ionization enthalpy is always decreases down the groups, but where it is increases, always the ionization enthalpy values are increases in the period but decreases in the groups. Okay. So only reason is there. What is the reason? Always increasing atomic size down the group. Due to this reason, ionization enthalpy also decreases down the group. Okay. Then electronegativity, which is represented by En symbol. What is the meaning of electronegativity? Electronegativity is nothing but it is a one type of ability. It is a one type of ability to attract the one electron from shared pair. To attract the one electron from shared pair. That is called what? Electronegativity. Okay, here it is decreases down the groups because of increasing atomic size down the groups. Only reason is there, common reason, that is atomic size. By increasing atomic size to decreases the electronegativity in the down the group, that is called electronegativity. Okay, here I have to give one tip for you. Always here always atomic radius, that is AR, and ionic radius, that is IR, values are increases down the groups. Similarly, ionization enthalpy and electronegativity values are decreases down the groups. We have to conclude by reading about this all parameters. Only one tip is that what? Always atomic radius and ionic radius is increases down the group, but here ionization enthalpy and electronegativity values are decreases down the group. Okay, always decreasing values are increases in the period, and also increasing values are decreases in the period. So that's why always group values are quite opposite to the period values. Period values are quite opposite to group values. Okay, then here chemical properties, right? Here oxygen electronegativity is very high. That means what? Oxygen is show the more electronegativity. It is a second more electronegativity of the periodical table, right? Oxygen electronegativity is very high, you know already. Then hence it will show only negative oxidation state. Due to presence of the more electronegativity value, oxygen will show the negative, that is minus. Okay, so that's why always oxygen is show the -2 value, but there is available some exception rules. What are those? How to provide it here, except in case of OF2. Here, for example, here OF2, the oxidation state of oxygen is +2. Generally, oxygen will show the -2, but when it is combined with the fluorine, it will show the oxidation state of oxygen is +2. Because of only reason is there, fluorine is a first, it will show the highest electronegativity. It will show the highest electronegativity. That's why fluorine will show the minus value, as well as oxygen will show the here plus values. Okay, so in OF2, the oxidation state of oxygen is +2. Okay, because of here it is fluorine will show the -2. When it convert here, then it is formed as the +2. Similarly, here O2F2. Okay, O2F2, fluorine will show the minus and oxygen will show the plus. That's why here it is +1. Here it is, fluorine will show the -1. It is oxygen will show the +1 oxidation state. Only except these two parameters, remaining all parameters, the oxygen will show the negative states, negative values. Okay, negative values, right? Then dioxygen, oxygen is present always in the dioxygen forms, dioxygen nature. Okay, here dioxygen is a gas. That means what? Oxygen is always present in the gas, but sulfur is solid. Here sulfur is show the which property? Solid property, because of due to the small atomic size and high electronegativity of oxygen. Due to presence of the small atomic size and high electronegativity of oxygen, oxygen behave as the gas. Oxygen behave as the gas, whereas in sulfur it will behave as the solid, because of only reason sulfur is containing less electronegative and sulfur is containing what is that? More atomic number as well as more atomic size. So that's why sulfur is present in the form of the solid state, as well as dioxin is present in the form of the gaseous state in the nature. Okay, these all are show the we have to discuss about it only particular room temperatures, right? Then here, due to large atomic size and less electronegativity, sulfur forms strong SS single bond. That means what? Strong sulfur bond, sulfur single bonds, and exist as a SC8. Okay, due to presence of, just I told you, due to presence of the less electronegative and also more atomic size, the sulfur is formed as the sulfur, single bond sulfur, and finally it is exists the S8. Finally, it is exists the S8. Okay. So, and also the molecules with packed ring structure, and sulfur is solid at a room temperature. Why the sometimes the question is came like this way? Why the sulfur is acting as the solid in the nature? The reason is what? The sulfur is present in the packed ring structure, as well as it will show the less electronegative and more atomic size when compared with oxygen. Due to this reason, the sulfur will acting as a solid state in the nature, whereas in oxygen is acting as a gaseous state in the nature. Okay. Then anomalous behavior of oxygen. Apart from this, the first point is oxygen is gas, all are solids. Just I discuss about the oxygen. Okay, oxygen is gas, all are solids. Then oxygen diatomic, other polyatomics. Why? Because oxygen is will show the diatomic. That's why the oxygen is always representing as the O2. Oxygen is always representing as the O2, whereas remaining all are polyatomic atoms, like SC8. It is a polyatomic atom of sulfur, right? Then oxygen is paramagnetic, other is diamagnetic. That means what? Oxygen will show the paramagnetic in the nature because of around the oxygen there is available some lone pair of electrons. Due to this reason, oxygen will show the paramagnetic in the nature, whereas remaining all are acting as a diamagnetic in the nature. Then, okay, oxygen forms hydrogen bonds in hydrides, whereas and also the oxygen also forms alcohols and carboxylic acids. That means what? The oxygen is forms the hydrogen bonds in hydrides as well as alcohols as well as carboxylic acid. It is also one special property of the oxygen. Okay, anomalous means what? Some special properties, some abnormal properties. Okay, when compared with their following elements. Okay, then here in oxygen there is available p pi multiple bonds. We discuss later about this p pi multiple bonds. Then oxidation states is -2 and +2 only with fluorine, other +2 and +6. This is about the special property of the anomalous behavior of the oxygen. And also the oxygen is forms the ionic compounds. The oxygen is forms always ionic compounds. And also remaining important anomalous property is the oxygen is will show the more electronegative as well as lower size, Due to these all reasons, oxygen will show the anomalous or a special or a abnormal property in the oxygen family. Generally, we have to conclude always the first element will show the anomalous property, and always the maximum last element will show the radioactive in the nature. In this group, the polonium is a last element. Therefore, polonium is example for radioactive element in the oxygen family. Right, my dear students, are you follow me? Right. Here, yeah, just I told you, dioxygen. Always oxygen is representing as the O2, like this. Here, the valency of the oxygen is 6 electrons. Okay. Here, just we have to listen here. Around this, here, oxygen, here, one oxygen atom. This is about the one oxygen atom. In between two oxygen atom, there is available multiple bond. What are those multiple bond? Here, one bond is acting as a sigma bond. Another bond is acting as a pi bond. That's why there is available multiple bonds in between any two oxygen atoms. And also there is available, here it is 1 electron, 2 electron, 3, 4, 5, 6. Okay, 5, 6. That means what? Around the oxygen, there is available 6 electrons. How you have to determine the 6 electrons here? 1, here 2, here 3, here 4, here 5, here 6. Because of the valency of oxygen is 6. Remaining this oxygen here 1, 2, 3, 4, 5, 6. Here also it is also satisfy the valency electrons. It is also satisfy the valency electron. By putting double bond here, it is obey the stable octet rule. What is the meaning of stable octet rule? That means what? The atoms where there is available 8 electrons around their structure. That is called octet rule. By showing octet rule, it will possess the more stability in the nature. So that's here also available the octet conditions. Here, yeah, how to calculate here number of electrons here 1, 2, 3, 4, 5, 6, 7, 8. That means what? Here to here, this position, this is called octet rule. 8 electrons are available here around the oxygen. Similarly, what about this one here? Around this oxygen 1, 2, 3, 4, 5, 6, 7, 8. That means what? This is also satisfy the octet condition. This is also satisfy the octet condition. In this condition, O2 is show the more stability in the nature. That means what? Around the, I mean, in between any two oxygen atoms, there is available multiple bond. What are those? One sigma bond. Another one is pi bond. Okay. Here, preparations of dioxygens. Here, when hydrogen peroxide itself, it is participate in the reaction to form water molecules as well as O2. Okay. Remaining mercuric oxide, that is H2, HgO, is itself, it is participate in the reactions to form mercury, that is Hg as well as O2. Here, PbO2 itself participate in the reaction to form PbO plus oxygen. That means what? By following these all reactions, we have to observe as the to releases here oxygen, to release here oxygen, to release here also oxygen. And one more thing, KCl3. By using KCl3, there is also release the oxygen molecules. Thus, we have to prepare the dioxygens from the for following equations, right? Then another method, by using industrial companies, we have to prepare the dioxygen molecules also. Okay. Now, properties of dioxygen. Already we know about the properties. What are, maybe once again repeat you. It is a colorless. Always dioxin is nothing but it is a always it will show as the colorless, and also odorless. It will show the diatomic gas. I told you just now. Always oxygen is containing di. Di means what? Both. That is 2. That's why oxygen is representing as always O2. 2 means what? Di. Okay. Diatomic gas and paramagnetic in the nature. I told you it is show the paramagnetic in the nature. Next, oxygen is highly reactive. It will show the highly reactive, but it is containing non-metal nature. Generally in groups always metal properties increases the down the groups. Generally in groups, metallic properties are increases down the group. Whereas here oxygen is a first element of this group. That's why it will show the non-metal property. Non-metal property, right? Then this is diatomic gas in strong oxidizing gas. This is also show the one property, that is important property. What is that? Strong oxidizing gas, strong oxidizing agent. Okay. Here, for example, here SO2 is react with dioxygen, gives rise to form SO3. That means what? Due to this equation, we have to conclude that the oxygen is acting as the strong oxidizing agent. Okay. Then it is second most electronegative element after the fluorine. That means what? The fluorine is a first most more electronegative element, and second one is oxygen. Why? Because the fluorine will show the 4.0 electronegative value. and also the oxygen will show the maximum approximately 3.5 above electronegative value. That's why dioxin is a best example for second most electronegative element in the nature. Okay. Then dioxygen react with the metals, non-metals to give oxides of the respective elements. That means what? Always dioxin is reactive with the metal or our non-metals to give their respective oxides. For example, here calcium is reactive with the oxygen, gives rise to form CO, that is calcium monoxide. Okay. Then another derivatives of oxygen is, that is what? Water. Okay, this is about the water. We discuss about the water. Okay, here water is liquid. Why the water is actually liquid? Generally, oxygen is gas, but water is liquid. What's the reason? You know already. The reason is water is liquid due to the presence of intermolecular hydrogen bonding. In water, there is available intermolecular hydrogen bonding. Due to this reason, water is acting as a liquid in the nature. Okay. Then water is a neutral compound due to OH, due to OH bond dissociation, enthalpy is more. Actually, why the water is show the neutral compound in the nature? Only one reason is there. It will require the more dissociation enthalpy or more dissociation energy to break out the OH bonds. Due to this reason, water is acting as the neutral in the nature. It is very, very important property. That's why how to more focus on the water properties. The first property, the oxygen, here water is show the liquid in the nature. The second property is nothing but what? It is always, it is the best example for neutral compound, because of it will require the more dissociation energy to break down the OH bonds of the water molecules. Right. Then here uses of dioxygen. Okay, here oxygen is used in many applications. Okay, number one is as an oxygen supplement in medicine. That means what? Oxygen also used for to prepare the medicines. Yeah, it is very, very important one. For respiration purpose. Without oxygen, there is no human beings, there is no life organs. That's why it will show the important role to breathe out the oxygen. That means what? It is also oxygen is plays important role for respiration process. Right? Then next point. In the industries for smelting of iron ore to form steel. To prepare the steel, we have to use the oxygen. Okay, right. Then in metal cutting and welding, in cutting and welding purpose, we have to use the dioxin also. Next one, last one, that is as on oxidizer in water treatment and rocket fuels. Okay, dioxin also used as the fuels in rockets, as well as it is also acting as the oxidizer. It is also acting as the oxidizer. So this is about the important uses of the dioxygen, right? Now, different type of oxides. There is available so many different types, but there is available apart from that, we have to discuss about the important one. What are those? Number one is neutral oxide. Number two is peroxide. Number three is superoxide. How to provide here example for here it is CO, N2O or neutral oxide. Then Na2O2, BaO2 or hydrogen peroxide are example for peroxides. Then KO2 and RbO2, these all are best example for super oxides. Okay. Now, ozone. Ozone is representing as the O3. O3 means what? O3 is nothing but what? Ozone. Yeah, O3. O3 nothing but what? Ozone. Right. Here we have to prepare the ozone. Preparation of ozone. Okay. How to prepare the ozone? Here first, oxygen is itself. It is involving the reaction to form as the O3. That means what? Ozone. Here it is delta H is equal to plus 14 kilojoule per mole. That means what? It is a endothermic reaction. That means what? It will observe the heat. By observing heat, the oxygen is converting as the O3 molecule, that is ozone. Right? Now, structure of ozone. Here, ozone. Ozone has angular structure. Angular means what? Look like this is nothing but what? Angular structure. Okay, this is nothing but angular structure. Look like bend. Some more bend, that nothing but what? Angular structure. Here, both oxygen bonds are equal bond length due to the resonance. That means what? These two atoms are show the equal bond length due to presence of the resonance. Okay, always just I told you yesterday, this symbol is indicating as the resonance structure. What is the meaning of resonance? The delocalization of pi electrons are called resonance. But here always the pi electrons are participating in the resonance, but not sigma electrons are participating in the resonance. Okay, my dear students, right? Then here in between these two oxygen atoms, there is available pi bonds. That means there are two bonds. One is sigma bond, another one is pi bond. That means there is available double bonds. In between this oxygen and this oxygen, there is no double bond. Here present only single bond. Okay. Here the number of electrons 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Up to this, it will obey the octet rule. It will obey the octet rule. Whereas here there is no double bond. By conversion of one
Ramesh
bond,
sir, conclude, sir.
time is up, sir.
Sir.
Okay, sir. I will complete with the 2 minutes, sir. Wait, sir. Here, okay. Yeah. Here, double bond is there. Here, single bond is there. By converting one pi bond here to here, then what happen? Here, the double bond is converting as a single bond. Here, single bond is converting as a double bond. Look like, okay. Look like here. Look like here. Here there is available double bond. Okay. Here there is available single bonds. Okay. This process is nothing but resonance structures. Right then. 1 minute, sir. Wait for it, sir. Properties of ozone. Always ozone is decomposes to provide the oxygen molecule. Here O3 is formed as the O2 by using decomposition. Then next second property, oxidizing property. Ozone is show the oxidizing in the nature. Oxidizing in the nature. Why O3 here? O3 is converting into O2 as well as O. Here O is nothing but O nothing but what it is called as nascent oxygen. It will show the more reactive in the nature. That means what? It is newly born oxygen. That's why it is called what? Nascent oxygen. It is more reactive in the nature. Then the ozone also acting as a reducing property. How? Here H2O2 is reactive with ozone to form H2O as well as oxygen. By during this one, we have to conclude it will show the reducing property. That means what? Ozone also show the reducing property in the nature. Thank you. Tomorrow I will meet you. Thank you. Can I continue, sir? Hello, sir.